Let's go deal for the first time with two sides. Not side angle side, but when you got two sides, then an angle. Or an angle, then two sides. What do I mean? We're going to want to solve this triangle. B is equal to 40 degrees. Side B is equal to 3. And side C is equal to 2. Maybe those are centimeters. I don't know what side. Maybe give it units. And I get your law signs up on the side and that all the angles add up to be 180. This is what we mean. That you have an angle, then the side, then the side. Angle, side, side. Or if you want to read it, side, side, angle. You know, you want to keep it clean. All right, angle, side, side. Oh, sorry, side angle. No, side, side angle. Getting confused. Yeah. So, side, side, angle. It's things that are given to you. Given two sides, that means we're going to need to do more work, and there's going to be some ambiguity to this. It's actually called the ambiguous case. In this first one, there's just no problems. So when you're given this piece of information, three pieces of information, there's going to be three different outcomes that could happen when you're given two sides in the angle. So like the ask case, this doesn't happen in side angle side, when the angle's trapped between the two sides. It's just this case when you have two sides and then an angle, or an angle then two sides. If you're given this piece of information, you could have, this could be describing just one triangle. It could be describing two different triangles. Or it could be describing no triangle. So for this first one, this is one frickin' triangle. There's nothing weird going on. So I'm just going to run it through as if we all know it's one triangle. Now in the next ones, there's going to be some strange, and there's going to be the tough parts. There's what's called the ambiguous case. If you want to go look it up on YouTube, see some more stuff, then where it goes in. There's a ton of stuff on YouTube, all about the ambiguous case. So for this one, we're just going to have one frickin' triangle. Look, I drew it down there. One triangle. All right, now here's how we're going to go. Typically, we want to just go get angles, but the problem is we got two angles that we don't know, so we can't just use that 180 trick. So everything's placed in here. What are we going to do? And when we use the law of sines, all we're looking for is, can we find an angle and its side opposite? That sets us up. That's our hookup right there. That tells us we can use this sine of 40 over 3. Now we can use this to go after whatever we need. Like, so we can't go get A because we don't know the angle and we don't know what side opposite. So that's not going to work. So we're really just pigeonholed into this. Like, we have no choice. We're going for angle C. We're going to go get angle C. Fortunately, I'm going to start leading into what the ambiguity is. We know for sure this angle is less than 90 degrees. Just look at it. Right? Right? If it was larger than 90 degrees, we'd have some problems. Let's see why. Okay, so we're trying to solve for C, but it's stuck inside of that trig function. So let's get the trig function by itself. So let's multiply by 2 on both sides of this equation. So we're going to end up with 2 times sine of 40 over 3 is equal to sine of C. And we're trying to get that C all isolated. There we go. Why did we learn inverses? So we can get angles out of arguments. We're going to hit both sides of this because we need to get that angle out. So we need to hit both sides with a sine inverse and a sine inverse. If you're ever solving for an angle and you're not using the little 180 trick, you're going to need to hit it with an inverse. So C is equal to, that just unravels, right? The inverse of the trig function will just pop it out as long as it's within the domain of the function. And that sure as hell is in between negative pi over 2 and pi over 2. Oops, I mean negative 90 and positive 90 degrees. This is an acute angle is equal to, and when we say it's sine inverse of 2 times sine of 40 degrees, all over 3. And we are going to find that C, if you punch that into your calculator, 25.4 degrees approximately. Hold on, I'm just going to round this. Oops, let's go with 25.37. My bad, I forgot we're rounding to 2. 25.37. So to get your practice punching this in, it's real easy to get fat fingers doing this. I'm telling you, to press two buttons at the same time or not use enough parentheses or let something go wonky. Dude, be careful. Be careful. So I'm going to fill this thing in and just go right here. This is 25.37 degrees. Or if you want to, start a list on one side and start going. Now we're still going to need to go get angle A, and we still need to go get side A. Well, angle A we can now get. We have two of the angles. So all we're going to do to go get that big angle is do 180 minus 40 minus 25.37. So we're going to find out that angle A is approximately, over on the right I'll use an equal sign, but when I do calculations I will not. I will say approximately 114 degrees, 114.63 degrees. We now have all of our angles. Now we needed to go get this angle here. Oops. We needed to go get this angle so we could go get that side. Now we're right back to that process we did in the first one. So we're going to say sine of 40 over 3, that same common ratio we used at the very beginning, is equal to the sine of that 114.63 that we found over that side A. Now we need to go get that side A, and we'll do that cross multiplication like we've done before. Run through and we will go get our solution. So we have A times sine of 40 degrees is equal to 3 times sine of 114.63. We'll divide out our sine of 40 and we're going to find out that A is indeed equal to 3 times sine of, let's write it inside, 14.63 over sine of 40. So let's get that into our calculators. 3 times sine of 114.63. I like to hit enter and then divided by sine of 40. And finding out that A is approximately, what's that, 4.24? Would that be good enough? I think that should be sufficient. So 4.24. And there we are. There we are. We got it solved. There's our solutions. Or maybe you like this better. But that's how we're going to run through when we have two sides and just the one angle, when that angle is not trapped between the two sides. Now what we're going to have to mess with soon is we're coming down to here. It's going to be right here is our danger. This is danger. Sine inverse only knows angles. Sine inverse of something only knows angles that are less than or equal to 90 degrees. If this angle would have been, say, 110 degrees, sine inverse wouldn't have told you that. It would have only given its reference angle. It would have only given its reference angle. So we're going to have this weird-ass ambiguous case that we're going to have to deal with. It's a little strange, so get your practice with that part. So I'm going to come back with another. Maybe it'll be no triangle, maybe it'll be two triangles, but we're going to explore both of those cases, and then we'll move on to areas. See you.